Okay. So today, like I said, we're talking about mid-segments and triangle inequalities. We want to keep mid-segments in our brain, although we're not going to address it very much in this lesson today. We do want to keep mid-segments from yesterday in mind. And then also triangle inequalities. So we want to be able to use something called the triangle inequality to determine if triangles are possible, given some certain side lengths and stuff like that. And then we want to also be able to list angles and sides of a triangle from largest to smallest based on these angle-side relationships that we're going to see today. So let's go ahead and get started. There it is. Okay. Zoom out slightly. So 6.5 triangle inequality. And angle side relationships. Okay. So the first thing that we need to know is kind of concerning angle side relationships. So we're going to do a quick illustration. So, and since none of you have your cameras on, I have no way to know if you're actually doing this, but humor me here. Let's do it together. We're going to imagine for a moment that we are making a triangle using our hand like this. And this is going to be the imaginary third side here. So kind of make an L with your hand or something like that. And so if I bring my fingers closer together and I make this angle smaller, what does that do to my imaginary third side? Well, it makes it smaller, right? Or if I make it bigger, if I make this angle larger, it makes this imaginary third side larger. So there's this relationship that exists between an angle and the side that it's across from. Usually if we were like in in-person class, we would do this by, doing kind of the YMCA Y and going, if I imagine that there's the third side is between my fingertips here, and you make it the angle wider, then that imaginary side, that distance between your fingertips gets bigger. And if you make it smaller, the angle, then that distance between your fingertips gets smaller. So it's kind of this intuitive relationship here that the small angle is across from the small side and the big angle is across from the big side. So that's what we're going to write down real quick. Smallest angle is across from the smallest side. And the biggest angle is across from the biggest side. So we can use this to order the sides and the angles of a triangle just by knowing one or the other. So in this case, we'll do a quick example here. We want to order the sides from largest to smallest. On this triangle here. So we have 50 degrees, 60 degrees, 70 degrees. A, B, C. So that's the sort of problem that we're going to be given here. And the only thing that really tends to trip people up with these is that they don't read the question. We need to read the question and realize that we want to order these from largest to smallest. So when I put them in order, I'm putting the largest one first and the smallest one last. So we go looking for, well, what's the largest angle? That's 70 degrees. So that's going to be across from my largest side. So my largest side is going to be AB. So that would come first. Well, then what's the next biggest? Well, angle A is the next biggest at 60 degrees. And that's across from my next biggest side, BC. And then the smallest angle, 50 degrees here, is across from the smallest side, AC. So this would be our answer. Largest to smallest, ordering the sides. Okay. So that's one kind of problem that we're going to be asked to do. Looking at the angles, order the sides from largest to smallest or from smallest to largest. Again, make sure you read the question. Let's see. The next thing we're going to be asked to do is the same kind of thing, but in reverse order. We're going to order the angles instead. We'll go from least to greatest this time. And our triangle is going to look like that. And we're given the side lengths, and we want to order the angles this time from least to greatest. So make sure you pay attention again to the directions, ordering the angles from least to greatest. Okay. So then, the smallest side is across from the smallest angle. So our smallest side is 4 centimeters. That means it's across from angle D, so that means that angle D is the smallest. That would come first because we want least to greatest. Also, if you're confused about how you tell what something is across from, whatever it's not touching, whichever angle is not touching the side is the one that it's across from. So like, for example, this side, the ends of this side touch E and F, but it doesn't touch D. So D would be the one that it's across from. Okay, then the next smallest would be 6 centimeters, and that's across from F. And then lastly, 7 centimeters is across from angle E. Okay, so that's kind of the first main idea of today, ordering the sides from largest to smallest and ordering the angles from least to greatest. I'm gonna have you guys try a couple real quick. First one. We've got this triangle here. Let's go, leave it like that. And we're going to order sides smallest to largest. There's your first one. And then the second one. Order the angles. Biggest to smallest. Okay, so take a minute or two, try both of those. When you think you've got it, type yay triangles in the chat. No, but you can figure out the third angle, can't you? Good question. What do the angles of a triangle add up to? Yep. So good point. On that first one, you're going to have to find that third angle before you can do anything. Good looking out. So yeah, if you haven't figured it out yet, that angle is supposed to be 35 since you go 180 minus 85 and 60 to get 35. All right. Anyone who thinks they've got it, what side did you put first on the first one? Which side went first? What's the smallest? All right, we have a vote for MN. Anyone else think they got the smallest side? We got a vote for NL. Anyone else have agreement, disagreement? What do we think? We've got two options here so far. Got another vote for NL. Another one for NL. All right, so it's looking like the general consensus is NL. So what's the smallest angle? That angle M, right? This one's the smallest angle. So if that's the smallest angle, then the smallest side is definitely the one across from that, which you guys got NL. So that's going to be the one that comes first since we're going smallest to largest. All right, then what comes next? All right, we got to vote for ML. Anyone else for ML? All right, we got some agreement there. The next smallest angle is that 60-degree one, right? So then the next smallest side is going to be across from that, ML. Nice job. And then by default, the last one, the biggest, is across from that 85-degree angle. That would be MN. All right. So yeah, pay attention to the order that you're doing things in. Remember on example 1, we went largest to smallest. This time we went smallest to largest. So again, that's why it's important to make sure we look at the directions there. Second problem, order the angles biggest to smallest. So what's the biggest angle going to be? Anyone think they got it? It's the biggest side. Anyone think they got the biggest angle? Q. Yeah, several people decided Q. I like that. PS is the biggest side, so Q would be the biggest angle since it's across from that one. All right, next biggest. What do we think? S. Nice job, you guys. Yeah, 10 is the next biggest side, so angle S would be the next biggest angle. And then lastly, angle P is going to be our smallest. Okay, so that is angle side relationships. That's one of our big concepts for today. The other big concept for today is going to be something called the triangle inequality. But before we move on to that, are there any questions from any of these? Any numbers or letters that we're not sure where they came from or how we decided that? Okay. Keep in mind, if at any point you do have a question, type it in the chat or unmute yourself and say so. But till then, we are moving right along, talking about the triangle inequality. And so for the triangle inequality, when we first start talking about that, if you have a ruler, great. If you don't, you can still get kind of the same idea from it. But we're going to do a little illustration here real quick. And we're also going to do a little bit of just kind of thinking about things. So the first question I have for you guys to ponder, do you think that you can make a triangle with any three sides? Like if I took 3 random sticks on the ground, are they guaranteed to make a triangle? If I were to put them together, what do we think? Or can we think of a scenario where they wouldn't make a triangle? Think they would make a triangle? Anyone else have an idea on this? Would they always make a triangle, or is there a scenario where they might not? Okay. I'm going to let you guys ponder that one for a moment while I do some drawing here. So I'm going to take my ruler. I'm just going to use the ruler function off of this. And I'm going to make a line that is 5 inches. And then let's make some other sides for this potential triangle. I'm going to make one that's 3 units long or 3 inches long. And then I'm going to make another one that's 2 inches long. So what do we think? That one doesn't quite make a triangle. Could I make a triangle with sides that are 5 inches, 3 inches, and 2 inches? Like if I were to squish it together a little bit more, maybe? Let's try it. I'm going to keep this same 5-inch long one. I'm going to make it as small as possible for this little triangle. See if we can get it to work. It gets really, really close, doesn't it? Like we've still got that teeny tiny gap. Can anyone see a problem with what might be going on here? 3 and 2 adds up to 5, right? So if I were to like lay them down exactly on top of that 5-inch line, so if I were to make, there's 3 inches, another color, and this one is 2 inches, it would fit perfectly, right? But is it making a triangle anymore? Not really, right? If it's a line laying on top of another line, that's not a triangle. Right, when the two sides add up to the longest side, we've got a problem. You can't actually make a triangle. So this is something, an illustration of something called the triangle inequality. So when the two smaller sides add up to equal the biggest side, or they add up to be less than the biggest side, we can't actually make a triangle. So, triangle inequality. All right, so the triangle inequality formally says that the sum of any two sides of a triangle must be greater than the third side. All right, so the sum of the length of any two sides must be greater than the length of the third side. And so really the ones that you need to check are the two smaller sides and see if those add up to be bigger than the third side. It can't be equal to the third side. It can't be less than the third side. It must be greater. So one type of problem that you'll see is you'll be given 3 numbers for side lengths, and they'll ask you, can this make a triangle? And so if we end up with a scenario like this one, where it's 5, 3, and 2, we would have to say, no, you can't make a triangle out of side lengths of 5, 3, and 2. So that's one kind of problem that we're going to see. So let's do a couple of examples here. Can the side lengths make a triangle? So for the first one, we'll have 3, 7, and 5. For the second one, we'll have 3, 4, and 8. For the third one, we'll have 3, 10, and 7. Okay, so for this first one, really what you need to check, again, is that the two smallest add up to be more than the biggest. So the two smallest are 3 and 5. So I would add 3 plus 5 to get 8. Is that bigger than my third side? Yeah, 8's greater than 7, right? So then we would say, yes, you can make a triangle with sides of 3, 5, and 7. All right. Well, what about 3, 4, and 8? What do we think? That's kind of our strategy here. We add the two smallest, and it must be more than the largest. So what do we think? Our two smallest here would be 3 and 4. 3 plus 4 is 7. Is 7 bigger than 8? No. That's a problem. So we would say no. All right, and then the last one, we have 3, 10, and 7. Our smallest two are 3 and 7. So we'd go 3 plus 7 equals 10. But that's like a scenario that we saw up here where we had 2, 3, and 5, where the two smallest equal the biggest when they're added together. So that's a problem. That's also not greater than 10. So no. So this is the scenario that works. These two are the scenarios that don't. When they add up to equal the third side, or when they add up to be smaller than the third side. That ends up being an issue. Okay, so that's one way that you'll see triangle inequality problems. You'll have three sides, and they'll say, can this make a triangle? And so we have to add the two smallest and decide that way. Okay. Any questions on any of these three so far? Any that we're not sure on how we made that decision? All right. The next kind of question that you're going to see is they're going to ask for a range of values for the third side. So they'll give you like the lengths of two of the sides, and then they'll say, what's a range of possible values for my third side? So, example number 2, if two sides are 4 feet and 10 feet, what's the range of values for the third side? Okay, so when we do this, when we see a problem like this, when we're looking for a range of values, we're looking for an inequality here. We want like, if the third side is x units long, we want an inequality of the smallest value of x to the largest value of x. So what we're going to do here is set up something that looks like this, where we have the smallest possible value here and the largest possible value here. Okay, so the first scenario is where we imagine that these two are the smallest sides. And if these are the smallest sides and I add them together, I can't have the third side be bigger than that, otherwise it won't make a triangle. So over here on the big one, we are going to add 4 and 10. And then over here is where we imagine that 10 is the biggest side. So what if the biggest side is the bigger number over here? Well, then if I go 10 minus 4, whatever I get from there, my third side can't be smaller than that. So on this side, we would subtract 10 and 4. And keep in mind, you don't want like a negative number ever. So you can subtract them in any order you like, but make sure you absolute value it, make it a positive number. Because we just want the difference between the two. So over here, we'd have 10 minus 4, which is 6. And then 10 plus 4, which is 14. So the range of values would be from 6 to 14. So I can have anything bigger than 6 or less than 14, and it will make a triangle. So that's kind of the idea we're getting at here. So if we have 2 of the sides, we can make up a range of values for the third side. So again, we add the values on the bigger end and we subtract the values on the smaller end. Okay. So that's the second kind of question that you'll see. And then the last kind of question that we're going to see is it'll give you 2 sides, kind of like we did here, and then it'll give you a possible third side, and it'll say, could this be the third side? Yes or no? Okay, so we'll see things like if 7 and 10 are 2 sides of a triangle, could 14 be the third side? And then we'll see something like, how about 20? Could 20 be the third side? Okay. So using what we know about triangle inequality and stuff like that so far, let's take a vote here. What do we think? If 7 and 10 are 2 sides, could 14 be the third side? What do we think? Type in the chat, yes or no, on 14. Could that be the third side? Actually, I'll do a poll real quick. All right, in the poll section, could 14 be the third side? Yeah or nah? What do we think? I'll give you a moment to vote. All right, we're pretty evenly split so far. What do we think? Need some more people to vote here. Could 14 be the third side? So if we think about it this way, 7, 10, and 14, could they make a triangle? Do the 2 smaller sides add up to be more than the third side? All right, we're still pretty evenly split here. Anyone want to be the tie-breaking vote? All right, in this scenario, 7 and 10 are the two smallest sides, right? So if I go 7 plus 10, we get 17. Is 17 bigger than 14? Yeah. So could 14 be the third side? Yeah. So yes, 14 could be the third side because the two smaller sides add up to more than 14. All right. So then, yeah, so it's got to be more than the third side. So then, same idea, but how about 20? Could 20 be the third side instead of 14? So could we have a sides of 7, 10, and 20? Same question in the poll. What do we think? Would 20 work? All right, so far we've got mostly votes for no. Anyone else have an opinion here? Would 7, 10, and 20 make a triangle? All right, looks like we got all no votes so far, and you guys are correct. No, 7, 10, and 20 could not make a triangle because, same idea here, if I add 7 and 10, because those are my two smallest sides, we get 17, and 17 is less than 20. So one way that you can think about it, if you think back to our triangle inequality illustration here, think about the biggest side. Is the biggest side going to have, like if you think of this as like the body of like a dinosaur, go with me for a moment here with our imagining, is it going to have two little T-Rex arms that can't quite touch to make a triangle? Or is it going to have, long enough arms that can actually touch and make a triangle? In this case, we'd end up with 20 units long, and then having T-Rex arms that don't actually have enough length to touch. But here we would have long enough arms that they can touch. They end up adding to be more than 14. But in this case, they add up to being less than 20. We would say no for 20. Okay. So those are kind of our three main types of triangle inequality problems. It's a lot of yes or no questions, and then some of like finding the range of value kind of questions. So I'm gonna have you guys try a couple real quick, and then we'll get to the assignment. First one. The sides are 8, 24, and 15. And you make a triangle. And then the second one. Two sides are 5 and 19. What is a range of possible values for the third side? Okay, so try those real quick. When you think you've got it, type got it in the chat. and then we will move on to the assignment. All right, we got about 5 people who think they've got it so far. I'll give you another minute, and then we'll talk. Okay, so for the first one, what do we think? Could we make a triangle with those 3 sides? Any ideas? Or what numbers would I need to add together in order to check? Which 2 numbers should I add together? All right, we got to vote for 8 and 24. Anyone else think they know which 2 numbers should we add together to check? All right, we got a couple votes for 8 and 24. We got to vote for 8 and 15. All right. Think back to the triangle inequality when we were doing those kind of problems. Add the 2 smallest. Yeah, so let's see. We got a couple more votes for 8 and 15. Yeah, 8 and 15 are the 2 smallest. So those are the 2 that we have to check. 8 plus 15, which gives us 23. So can I make a triangle out of 8, 15, and 24? No, I cannot, because 23 is not big enough. It needs to be bigger than 24. All right, so no, I can't make a triangle with 8, 24, and 15. Remember our strategy, add the 2 smallest, needs to be bigger than the third. Okay, then our range of value problem. So we're looking for a range of values like this, where we have a number over here and a number over here. Anyone get a range of values here? Or what number went on the left and on the right? Or you can type your inequality. Anyone want to share with us what they got? Remember, over here we subtract, and over here we add. So if I subtract 19 and 5, and then I add 19 and 5, we get our two numbers. So 19 minus 5 gives us 14. 19 plus 5 gives us 24. That's going to be our range of values here. That means my third side can be anything bigger than 14 or less than 24. Okay. So that's kind of our, these are the two really main types of problems that we're going to see for that. And then in addition to it, we've still got the ordering the sides and ordering the angles from largest to smallest or smallest to largest. So now we're going to go ahead and take a look at the assignment. And we'll do a couple of them together. So go ahead and jump over to Google Classroom and open up the Big Ideas assignment that I just posted there. Up at the top, we've got Big Ideas. It's a 6.4 and 6.5 combined practice because I did toss a couple of 6.4 questions in there for you just to make sure that we've got the 6.4 stuff down as well. So that was all that mid segment. All right, so like the first one. The first one says that DE is a mid segment of triangle ABC. Find the value of X. So remember, for mid segments, we have this relationship that this one is half of the side it's across from. So if this one is half, that means it's half of 26, which is 13. Remember on these assignments that you can use the check answer key and that you should use that little checkbox. If you get it wrong, you've got a couple more tries that you can, change out your answer here. So there's the first one. It's a mid-segment problem. The first two or three of them are all going to be mid-segment problems. Okay. So I'm going to let you do the rest of the mid-segment problems. We're going to jump to something like number 5. 5 says to list the angles from smallest to largest. And on this one, it's where we're just kind of dragging things around, click and drag. So the smallest is going to be on the top. The largest is going to be on the bottom. So we want to make sure that we know how to use the click and drag to order things around. Okay. So the first step is making sure we're comfortable clicking and dragging to order them and put them in order from smallest to largest. Second thing we want to do is look at the triangle here, look at the side lengths. Which one should go on top? Which one's the smallest? J, K, or L? What do we think? J, thanks Alex. Yeah, that's going to be the smallest because this is the smallest side over here, KL, and it's across from J. What goes next? Is it K or L? Yep. So then L comes last, and you can check your order just like that. It'll tell you which ones are in the right spot. All right, so there's a triangle inequality, or not triangle inequality, angle side relationship problem. Let's find another. Okay, here's a triangle inequality one. This is number 12. So we've done 1, 5, and now we'll do 12, just to get one of each type together. So it'll say, is it possible to construct a triangle with side lengths of 28, 17, and 46 units? If not, explain why not. Okay, so looking at this one, which two should I be adding together? Out of 28, 17, and 46, which two should I be adding together? (17 and 28). Yeah, because those are the smallest. You got to add the smallest. So 17 plus 28 gives me 45. Is that big enough? No, not bigger than 46. So that's a problem. So we would select this one. 28 plus 17 is not bigger than 46. And we click the checkbox and we got it. Okay. So there are 15 total problems on this assignment. We just did 3 of them. And they all pretty much go like those 3. There might be 1 or 2 in there that are a little bit more challenging than the others, but I'll be able to answer questions and we can go over some together in class tomorrow if you run into ones that you have a hard time with. So make sure you write it down. If you have a hard time with number 15, write down 15 so that you remember to ask that one in class tomorrow. Okay. If you have questions, feel free to stick around. Otherwise, this is the part where you guys get to go and work on your own. I will post an exit ticket in just a moment, but have a great rest of your day.